So in this video, we're going to do one more problem with the sum of the forces. So we have a T box here, and I'm going to lift it up with a force of 735 newtons. Now it says tension. So what we're doing is we're assuming that I tied a string around this and lift it up with the string. That's fine. You can just call that T. Previously, we called it like the force of the pole or the force of the hands. T is just fine. So let's do our free body diagram. Since I'm lifting it, it's off the table. Now, gravity always pulls down, but there is no normal force. There will be a force of tension pulling up. So in this case, it's off the table. I'm pulling it up. It's almost certainly accelerating. So ma equals T, because T is in the positive y direction, minus mg, which is in the negative y direction. Now, you may remember from yesterday, and I'm not going to go through the math again, but the box was 75 kilograms. I'm pulling upward with 730, I'm pulling upward with 800 newtons, my bad. With 800 newtons. Sorry about that. And the weight of the box is 735 newtons. So at this point, we're going to just do a little tiny bit of algebra. Sorry about that mistake. And divide over and see what we get. Yeah, 0.867 meters per second squared. There's another example of that kind of problem. What I really want to get into today is contact forces. So this is a case of we're pushing two boxes, but we decide to go make our lives easier. We're only going to push on the blue box here. We're going to let the blue box then push the orange box. So a 10 kilogram box is placed next to a 5 kilogram box, and we push it. So let's do the free body diagrams. And I'm going to do them right above the boxes. So the 10 kilogram box has an mg. In fact, since it's heavier, let's make that a capital M. I like that better. And then a normal force. We're pushing on the box with 20 newtons. Now that 20 newtons is to the right, so I'm going to put it right there. Now hold off on that other force for just a second. Now we'll move over and do the free body diagram with a 5 kilogram box. Well, mg goes down, and I'll use little mg, and normal goes up. Now what's pushing on the 5 kilogram box is the wall, the side of the 10 kilogram box. That's what we call a contact force. And I like to just use C to make life easier. Some books use F sub C. Nothing wrong with it. It's just I'm trying to make life better. But we got to remember Newton's third law. For every force, there's an equal and opposite force. So if the blue box is pushing on the orange box is also pushing backwards. The orange box, you can think of it's resisting the motion. Well, let's set it up. Let's look at the blue box separately from the orange box. And we're only going to worry about the x direction, because it's not going to move vertically. We're just pushing them horizontally across a floor or something. So MA, if we look just at the blue box, 20 newtons is going in the positive x direction, and the contact force is resisting. Now I know the mass is 10, so I can put that in. And I know I'm not fussing around too much with the significant figures here. These problems are difficult enough without worrying about the significant figures for right now. And we're actually pretty much stuck at this point, because I have two variables. I have an A and a c, and I can't solve for the two variables, not with a single equation. That's why we had to look at the orange box. Now the orange box is also going to move in the x direction. The only thing pushing it is the contact force. That's it. And the box is 5 kilograms, so we can go ahead and put that in. I've got 5a is equal to c. Now we've got a systems of equations set up. You could solve it by substitution if you prefer, or you could stack the equations. I'm going to stack them. So let's write this equation here. I'm just rewriting the equation for the blue box. Then I'm going to do the same thing for the orange box. Now you might say, you left a big space there. Yeah, I wanted the C's to line up. Now I'm going to add equations. 10 and 5 is 15a equals 20. But notice what happens. That's why I moved the C way over here. Negative C and positive C cancel. Now I can simply divide both sides by 15, and I have the acceleration of both boxes. Sometimes students have an alternate way to solve this problem. Don't do that. I'll tell you why. Because if you don't set up both equations, you're not going to be able to find the contact force. You can get the acceleration. There's a simpler way to get the acceleration, and some people know the shortcut or they figure out the shortcut. But I'm not going to show that because I want you to do it the full way so that we can get both variables. Getting the contact force is really easy now. We could either put the A in this equation or in the equation for the orange box. I think it's easier to put it in for the one for the orange box. So it said 5a equals c. So 5, we now know the acceleration is 1.33, and the contact force is 6.67 newtons. The acceleration of both boxes is the same. They're both getting pushed, and they're both going to move in the same direction. The contact force is positive 6.67 for the orange box, because it's the contact force that's pushing the orange box. The contact force is negative for the blue box because the contact force is resisting for the blue box.